All right, physics students, today you're going to be doing the beat frequency lab. And in this lab, you're going to be listening to different tones and looking at their waveforms, and then listening to how the two tones interact and produce what we call beats. And so the first thing you're going to do is open this link right here. And this whole lab you'll open from Classroom. And so basically you can see here there are these different waveforms. There's one waveform on top, one in the middle. They combine to form the third wave. Now here's the thing, if I just turn it on right off the bat, nothing happens. I can move these around. You can kind of look and see, but I can't hear anything. And so that's really not the way I want this to work. Also, I can zoom in and I can zoom out. But what I need to do to make it work is I have to go up here to waves, click that, and then come back down here to wave interference and beat frequency. And now, if I play sound on or off, you can hear that. And you can hear that kind of wobbly sound. It's going whoa, 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 like that. And basically that is what we call beats. Every wah of the wah wah wahs is a beat. And so what does that look like? If I zoom out or zoom in here, and if I change this one up here a little bit more, see if we can get here's a good representation. So here I have one frequency, here I have another one, and then here you see kind of these bundles of waves where you have complete constructive interference in the middle and then almost complete destructive interference right here. And the amplitude, remember, is related to the volume. So here's a big wah, wah, wah. And if I play it, that's too fast for me to hear. I mean, it sounds, you can hear that vibration, but you're not able to pick out the distinct beats that you can see here. So graphically, we can see that this is happening, and we know that the frequencies here aren't the same, but it's hard to hear. If I want to hear those differences, I need to make sure that these frequencies are really within about 5 of each other. So if this is 230, I switch this down to, I don't know, 231. Whoa, whoa, whoa. So that's a sort of an aural, A-U-R-A-L, recognition of what's going on. Like I said, if you get over 5, it's really hard to tell. If I overlay the waves, I check that box right here, you can see sometimes they line up perfectly and sometimes they're just out of phase a little bit. And again, it produces that sound. And this is how people can tell whether something's in tune or not, one of the ways. Okay, so you can type in the frequency you want here, the frequency you want here. There are limits to it. But other than that, just follow the directions on the lab. I should probably stop that because it's really annoying. All right, and follow the directions. There's one where part 1, you just kind of play around with the stuff and calculate some frequencies and figure out the period. Then you've got part 2. This is where you're going to actually listen for that, like what we were just hearing. And then part 3 is where you're going to do it visually, where you're not going to be able to, again, pick out like how many beats there are. You're not going to be able to time that in 10 seconds. So that is the lab for today.